Hello everyone, welcome back to Ganix.com. This is your friend Ashish. Hope you're all doing great. Today we'll be starting with our first project in our Breadbotics workshop. Our first project is a light operated robot called Lebot. The main concept that we'll be using in this project is the operation of a robot using LDR and relay. In today's class, we'll be covering LDR, relay and other components that we'll be using in this project in detail. And in today's class, we'll be also making our first robot. So get ready to make your hands dirty and enter to the amazing world of robotics. So friends, before proceeding to the project, let's check the components that are present in your kit. All of you must be having your kit with you right now. If you still haven't ordered it, then log in through our website www.gyanx.com, that is gyanx.com. Explore the new world of robotics and grab your kits as soon as possible. In this project, we'll be using the following components: two 10K resistors, one 5V DPDT relay, one light dependent resistor, a single strand wire, two 12V DC motors, one 9V battery, one transistor C1815, two wheels, one caster wheel, a breadboard and a sunboard. Apart from that, we'll be using the following tools: a ruler, a marker, a cutter and a wire stripper. Since we are having our Breadbotics workshop, we'll be doing all our circuits on a breadboard. A breadboard, also known as protoboard, is a type of solderless electronic circuit building. You can build an electronic circuit on a breadboard without any soldering. A breadboard is used to build and test circuits quickly before finalizing any circuit design. The breadboard has many holes into which circuit components like ICs and resistors can be inserted. It is reusable. This makes it easy to use for creating temporary prototypes and experimenting with circuit design. Now let's see the internal construction of a breadboard. A typical breadboard layout consists of two types of region called strips. These regions are bus strips and socket strips. Bus strips are usually used to provide power supply to the circuit. It consists of two columns, one for power voltage and the other for ground. The breadboard has strips of metal which runs underneath the board and connect the holes on the top of the board. Before starting with the project, let me give you a brief introduction to the components that we'll be using in it. First of all, the resistor. The resistor, the most important of electronic components, are a critical piece in just about every circuit, and they also play a very major role in our favorite equation, the Ohm's Law. The resistor is an electrical component that reduces the electric current. The resistor's ability to reduce the current is called resistance and is measured in units of ohms. If we make an analogy to water flow through pipes, the resistor is a thin pipe that reduces the water flow. Combining the elements of voltage, current and resistance, Ohm developed the formula V equals to IR, which is called the Ohm's Law, in which we have V equals to voltage in volts, I equals to current in amperes, R equals to resistance in ohms. Let's say for example that we have a circuit with a potential of 1 volt, a current of 1 ampere and resistance of 1 ohm. So using Ohm's law, we can say 1 volt equals 1 ampere into 1 ohm. Let's say this represents our tank with a wide hose. The amount of water in the tank is defined as 1 volt and the narrowness of the hose is defined as 1 ohm. Using Ohm's law, this gives us a flow of 1 ampere. So from this we can say, for a fixed voltage, as the resistance increases, the current decreases, and similarly for the fixed voltage, if the resistance decreases, the current increases. So let's see how we can calculate power in a circuit. Power is usually calculated by multiplying voltage and current, that is P equals to I into V. But by applying Ohm's law, we can also use the resistance value in calculating power. If we know the current running through a resistor, we can calculate the power as P equals to I square into R. Or if we know the voltage across a resistor, the power can be calculated as P equals to V square divided by R. Now let's see the different types of connections of resistors in a circuit, the series and the parallel connections. Resistors are paired together all the time in electronics, usually in either a series or a parallel circuit. When resistors are combined in series or parallel, they create a total resistance. The series resistors. When connected in series, resistors values simply add up. As we can see in the circuit, R1, R2 till Rn are connected in series. Therefore, R total is R1 plus R2 plus Rn minus 1 up to Rn. So for example, if you just have to have a 12.33 kilo ohm resistance, seek out some of the more common resistors value of 12 kilo ohm and 330 ohm and butt them up together in series. Now let's see how resistors are connected in parallel. The total resistance of n resistors in parallel is the inverse of the sum of all inverse resistances. That was confusing, right? I'll explain you with a very simple equation. In the circuit shown in your screen, R1, R2, R3 till Rn are connected in parallel. Therefore, 1 by R total equals to 1 by R1 plus 1 by R2 till 1 by Rn, where n resistors are in parallel. To find the total resistance, invert each resistance value, add them up and invert that. You will be getting the total resistance of the circuit. Now let's see how to read color codes from resistors. The value of the resistor is marked on the body using colors. Every color is different number and you can remember this number or you can just use a table. We can calculate the resistance of a 4-band resistor using the formula R equals to bracket start 10 into digit 1 plus digit 2 close the bracket into the multiplier. In the resistor given, we are having digit 1 as green, digit 2 as blue and the multiplier as yellow. So R equals to 10 into green plus blue multiplied by yellow. From the table or from the trick that I had already said, we'll have 10 into 5 plus 6 multiplied by 10 raised to the power 4. That equals to 56 into 10 raised to the power 4. This gives the resistance of the resistor. For 5 or 6 band resistor, we are having the following formula. R equals to 100 into digit 1 plus 10 into digit 2 plus digit 3 bracket close into the multiplier. As we can see from the table, black signifies for 0 with a multiplier of 1, brown signifies for 1 with a multiplier of 10, red signifies for 2 with a multiplier of 100 and so on. We can remember this table using a very simple trick, that is B. Roy of Great Britain has a very good wife. The first B stands for black, the second one for brown. In Roy, R stands for red, O stands for orange, Y stands for yellow. In Great, G stands for green. In Britain, B stands for blue. In very, V stands for violet. In good, G stands for grey. And in wife, W stands for white. In all 4, 5 or 6 band resistors, the last band signifies the tolerance. In the resistor given, it's a 4 band resistor with the last band as silver. So the tolerance is plus minus 10%.